Good morning, ladies and gentlemen, and welcome to our debate this morning on metrology in the inspection process. AOI needs to become data-driven to work alongside SPI and X-ray to deliver measurable feedback in real time to the placement machine. A panel of global leaders will debate this challenge and chart the course for inspection equipment and its critical role in the smart factory environment. I'm delighted to be joined by a very illustrious panel. To my extreme left, we have Herald Eppinger for Ko-Young. To his right, we have Dr. Subodh Kulkarni from CyberOptics. To his right, we have Carsten Salewski from Viscom. And then to my left, we have David Bennet from Mixtec. Welcome, gentlemen. So, I'm going to start off with the obviously first question. I'll start from the end. So, Herald, how important is metrology in the inspection process?
I think we all realize that it's a key for the success of the process, and the reliability of the metrology is important to rely on data later. And the complexity becomes more and more, and we have to adapt this also in the machinery, in the whole process. So that's key, how to understand. Okay,
so you're saying you need data for the reliability aspect, yeah? Okay. Dr. Subodh, what is your view on this?
Yeah, our view is somewhat consistent. We are all seeing similar issues as circuits are getting more complex, the parts are getting smaller. Metrology was always an important factor in inspection, always was there. We always collected data, but customers are demanding more and more of the data, particularly the high-end demanding customers. In a way, my view is that semiconductor industry, which is where my background comes from, metrology always played a big role in inspection in semiconductor industry. And to some extent, as substrate like PCBs are becoming, if you open an iPhone X right now, it's hard to see a PCB in an iPhone X. And when you are making those kinds of very advanced parts, metrology plays a very important role in inspection.
Right, okay. Carsten, are you getting a lot of requests for more and more data coming from your customers?
Yes, I think the AOI and X-ray systems, I mean, we're the sensors of the line, right? So talking about Industry 4.0, it's certainly, that's where the data comes from, and there comes a lot of data. Even you can save every image of every pin and learn about your process.
No.
Metrology is important, but we do that for over 30 years. Viscom is basically an image processing company from the beginning. So when you do feature extraction, you have to measure something, areas, features, width, length, and sometimes defects are identified by a measurement value. Sometimes it's an attributive test where it's color, for example. You don't have to necessarily measure color. It's a yes/no decision sometimes.
Right. Okay. But you still really need measurements, I guess, to be able to send data to make a correction, or are you saying that on images you just use a yes/no thing to work?
The thing is, Trevor, it's being talked about as if it's something new. I'm sure all of us have been doing metrology from day one.
Yeah.
We've all been measuring something, and that is metrology. Yes, it's more demanding now because we've got the buzz of 4.0 coming, and people are looking to have the perfect production line, which is basically a line that's controlling itself. You can only do that if you're measuring because of accuracy of placement and things like this, in volumes. So all of this put together, in my mind, is metrology. It's measurement, right. It's figures, it's numbers for accuracy, repeatability, sustainability of the process, and improvement of the process. Yeah. How can you improve if you don't know where you are? So it's numbers. It's all numbers.
Okay. So let's move on to my second question. And given the nature of solder paste, is it possible to make every potential defect a data-driven decision? We'll start with Herald on the end.
It's quite difficult to say what is a defect because it's related to the tolerances and what you expect. It's getting more and more that you have to stabilize the process. The defect is not the goal anymore. Of course, we have to catch the defect. The understanding of the root cause of the defect, that's the goal. We have to support our customers That's the only chance. Catching the defect, yes, it's a must, but learning from is much more important. And again, that is now the data we have to analyze and to provide and to proceed. Yeah.
Right. Okay. Dr. Subodh, do you have a?
I'll add that it's not, I mean, the question is not just can every defect lead to a data-driven decision. I mean, because you are dealing with a statistical sampling here, you are looking at trends. So it is a collective decision of where the process is, what may be happening with the defects, and what the statistical impact of that is. So I do think AI is going to play a bigger and bigger role, and that we definitely see where the demanding customers want to see trend analysis and more of a macro decision-making process on what do these defects mean, how does it impact me overall in my yield and other areas.
Yeah.
So it isn't a single defect discussion.
Okay. Carsten?
Yes, so data-driven decision, of course, there's data always, but I think sometimes we mix up measurement and metrology with inspection. So if you really have a measurement system, you have to have a gauge R&R process, you need a resolution, let's say factor 10 of the smallest feature you want to measure, or the smallest size. And that's sometimes mixed up a little bit. So the quality of the data is the most important part. And if you have let's say a bad signal at some points, you might be right most of the time with your good-bad decision. But we do that for a long time, that we not only track good-bad results in our SPC system, we actually keep track of the measurement values and see how consistent they are. Mm-hmm. And then you know actually that you have a stable measurement of your inspection machine.
I think you're right. I mean, I think there's value in both because obviously in SPI you're picking up data, but then when it comes down to say post-placement 2D AOI, you get a lot of images, and you look at some of these images that you can tell a number of things much quicker visually with these images than you would by purely getting data off it.
Yeah, your original question where you were saying, can we control it? Yes, we can all measure it. Yes, we can all see it. But one of the critical things which I think the industry needs to look at more than the inspection companies is if you take an example of perhaps a dropped component. Yeah. Yes, we're all going to see it. We're all going to catch it. It might even be under a BGA, and we'll still all catch it. We'll all see the lift. The issue is, for process control, why did it get dropped? And that isn't a single issue. That could be one of several factors. It could be there's a bit of paste that's been caught in the nozzle. The nozzle could be worn. The feeder could maybe not have been put in correctly. The axis or the setting for the feeder could have been human error and set up wrong. And all of these things, then you have to add the fact that most pick-and-place machines have a drift in time. When you look at all of that, we can measure this. We can see that the accuracy of placement is moving. Yeah. But you cannot say, oh, do that and it fixes that, because it could be do that or this or this or this or this.
Yeah, I think that's a good point. I mean, Herald, for example, you look at a stencil. Quite often, there could be a number of reasons why a stencil is blocked. It could be dry paste. It could be a whole range of different things. And as David's just pointed out, same in the pick and place situation. So, can we really use data in every instance, or can we just use data to narrow down some of the potential defects?
I think yes. You have to differentiate between the things where are obvious, right, and then the things which slowly appear in the process. The preventive action has to be taken, but we also see much more that people are spending more control mechanism or systems also to inspect the stencil after the cleaning. So we get a lot of requirements in kind of mechanical inspection of the stencil, because to figure out if the stencil is damaged. It's also part of the process to make sure that things in the process are more visible and under control.
Right. Okay. Let's move on to our next question, which is, are current systems able to deliver results of quantifiable yield improvements? Now, this is one of my pet topics, and that is that everybody's talking about this smart factory, Industry 4.0, optimization of the line. SPI is talking to stencil printers, etc. But can we get quantifiable results on yield improvement that a manufacturer can then apply to their metrics, wherever they're making, and say, okay, that's what my ROI is going to be if I invest in one of these SPI systems that talks to printers? Who wants to start with that?
Yes.
We can say that all together, maybe.
Yes, I agree as well.
Let's vote. Yes.
We wouldn't be here if it wasn't the case.
Yeah.
Okay.
I'd like to add another thing into that. I've been involved in sort of data for a long time, well before I worked with Mixtec, some 10 years before that. We were running whole factories doing exactly what 4.0 is saying. So this isn't new. This was companies like Ericsson and Motorola back in the day. And what we were able to do with them was monitor everything from when the materials needed to be kitted out, which lines they were going to, when they would run out on the machines. We were able to physically change the settings on some of the major placement companies in the world. And it all sounds wonderful. And then you've got the situation where placement company X is being adjusted by AOI company B, and they're saying that thing is messing up my machine. And there's going to be a lot of cross-company issues when inspection companies are saying to other pieces of equipment, you've got to change, you've got to do this, you've got to do that, you've got to do that, because they also all put their hands up and say, best in class. And if we keep saying, no, you're not, then this whole 4.0, hands tied, everybody's friendly, walking down the road together. I've been there, Trevor, and it doesn't work.
So what you're saying here is that, yes, you guys know that the quantifiable difference if you use a Viscom SPI system with a deck printer or a Viscom system with a MPM printer, but you don't want to make that public because you've got a relationship with both companies. No?
No, I don't think that's the case. I mean, all the machines can talk to all other machines, and I mean, that's not new anymore. So a closed loop is today something that's standard, and I think we will come to a stage where everybody talks to everybody.
Yep.
Maybe make the case for the IPC CFX initiative. That might be something that changes a little bit this proprietary interfacing, or there are many others out there. Mm-hmm. But no, I mean, what you're saying is right. The data was there all the time. I mean, from the beginning. The question is, what do you do with the data? Does the customer take the time to analyze his process and improve it, or is it just just do it, get it out of the door, next one, and without looking at the process, and improve yield? So certainly, how would you know your yield if you don't have good quality inspection at the end of the line? You wouldn't know.
Right.
That's the measurement gauge, the last gate to know how good you actually are.
I'm just thinking for the doubters, though, that say, "Oh, this Industry 4.0 thing is a big marketing hype. It's a lot of rubbish," which of course it isn't.
It's a great initiative of the German.
The point is that they're wanting evidence of what potential yield improvement they're going to get.
Trevor, I can tell you, as far as utilization, just utilization, the improvement when you're monitoring a complete line, what we used to do, we used to run the line for 10 days with all of the connection. But in those days, it was all daisy chain linked. And we would be monitoring from the printer to the post reflow, and we would have the whole line collect all the data but not feed back anything, just monitor. So this is 10 days of, this is where you are. Then we would turn it all on, and they would be getting the prompts. Oh, you need to change the paste. Oh, you need to get your materials ready. Oh, you need to do this. They followed it for 10 days. We then had, that's what you were without the information. This is where you are with the information. And typically, it was about a 35% utilization improvement. That alone will pay for 4.0. That was every customer we went to, that was the situation. The big problem that you had was it was all encompassing. You had materials, you had maintenance, you had production, you had quality. They were all together. And when you're explaining it, it's a committee. And any one of us who's ever tried to sell to a committee, I will tell you, it's a nightmare because they're all expecting someone else to foot the bill.
Yeah.
So they all like it, but they're all, well, maybe he'll pay for it. Yeah. So 4.0 is a new name for something that's been around over 20 years. Right. It's just using it.
Yeah, totally. I agree. I mean, and there's two main areas, as I say, that the potential benefit is. One is the line optimization, yield improvement. The other one is, of course, improving the supply chain and materials getting to the line and reducing machine downtime, basically.
Yeah.
Yeah. Okay.
But one comment I would like to make is it's quite ironic, our industry. It's famed for jumping all around the planet looking for low-cost manufacturing. You know, we could have all had the factories stay in our own countries if we had all been able to do this for our customers years ago. There was no need to run after low-cost labor. We could have almost reduced the labor to a negligible handle. If you can tell a guy in a line what's going to happen 10 minutes before it happens, he can stroll down to the end of the line and change the paste or whatever he's got to do. Instead of having all these low-cost people stood on the lines waiting for something to happen.
Yeah. Okay. Harold.
One comment, because I would like to take the mandate from our customers. We are talking about first pass yield improvement, and I think our customers are already very, very, very good. Mm-hmm. They are professionals.
Yes.
But the critical part beside the first pass yield is to keep the yield high. You can set up easily. You can spend a lot of time, a lot of money, can get it up. But I think it's much more important also to keep this during the process. I fully agree. We have influencers, material process, humans, the operators, and to keep this process on a very, very high level, that's our goal, what we have to deliver as an information and the tools to really not to go from 50 to 70. That was in the past. We are talking about a small percentage to improve.
I think most companies are doing 95% first pass yield. Yeah. So this is what I'm getting at. I mean, I think that the potential for improvement is maybe 1 or 2%. But what is that worth? A manufacturer can obviously look at what he's building and his costs, etc., and apply that 2% to see what it's worth. And that was really where I was getting to.
Yeah, I think what you just said, that's right. I mean, have we done that 10, 15 years ago? We were able to do it, but it was a big effort. Today it comes with the machine, because you have the measurement data, you have the calculation power, you have the central computers that can store all the data, and I think it's much easier, or it's less effort today, to improve your yield from 95 to 96% than it has been maybe 15 years ago.
Totally agree. Yeah. Totally agree.
At the risk of sounding contrarian, I will say that if for advanced products, the yields are not at 95%, and in many cases we find, like the latest memory chips, right now there's a serious shortage of memory chips right now in the industry. Everyone is aware of that. Yeah. And there's acute shortage. New technologies are coming in the memory industry, and the yields are not even close to 95%. And in those cases, inspection equipment becomes a critical enabling tool to improve the yields to the 90+%. So these guys are starting at yields much, much lower than 50% right now. And that is a serious issue at the high end of memory manufacturing, for instance. Right. So inspection is a critical enabler in those cases to drive the yields up. So it's not just a question of 95 going to 96. In advanced products, you are helping processes stabilize themselves to get from 30, 40% to 80+%.
Okay. Now I think you make a good point.
Trevor, could I just say with that, I totally agree with my colleagues. One of the things as well, first pass yield, as Dr. Subodh said, we have customers who are experts. They are superbly good at manufacturing circuit boards to very high quality in most cases. There are, of course, situations, like you've said, where there is a technology that's struggling. Any one of us could help these people. So this whole 4.0 is good. We can give them the tips. We can help them improve. But those that are already in the high 90s, what they're going to see is maybe half a point, a couple of points go on there, because they haven't got much further to go to be perfect. But when you combine that with the actual utilization of the line, when you put the two together and they start getting a manufacturing lift, that's when it'll happen. That's when they'll see the real benefit.
Okay, let's move on, gentlemen. Let's go on to our next question is, what other process benefits would a metrology-based system bring? We'll start at the end again with Harold.
I would say transparency.
Yep.
It's very simple. The process becomes transparent and visible for everybody, not only just the high-skilled experts. And that's the most benefit I see. What we can generate out of it, will bring the future with the Industry 4.0.
Actually, we're starting to run out of time, so I want to get a couple of other questions in if we can. Dr. Subodh, maybe you can say, do you think that post-placement AOI is going to become a critical element of the smart factory line?
It already is, I would say. I mean, post-placement AOI is a critical component of smart factory line today.
But a lot of people tend to put their AOI post-reflow rather than post-placement.
It depends on the customer and the configuration, but many of the really quote-unquote smart factory lines are using AOI in the post-placement, not necessarily post-reflow. They certainly have post-reflow. That's how AOI started. We all know that historically. But in the smart factory configuration, I would say many customers who are wandering the trade show floor here are thinking AOI bigger than just a post-reflow.
Okay.
It depends on the process. I mean, it might not be the biggest benefit to have a very accurate post-placement system, inspection system, because the pick-and-place systems have measurement capabilities built in, and they correct the process by taking a picture after they place the component. So for those customers and those processes, the post-placement is maybe not the most important inspection systems in the line. Mm-hmm. One word to metrology-based systems. Don't underestimate, and I think that's a critical part, the calibration process of a real metrology-based system. You need to have a process in place to certify your AOI system to be a real metrology system. So that's something to take into account, I guess.
A lot of people that are doing post-placement are doing 2D post-placement, not 3D post-placement.
Obviously, the reason is the volume's been checked previously by the SPI machine. Yeah. So now you're putting a component down very accurately on top of these pads. When you come out of there, as has just been explained, when you use the top-end placement systems, they're all self-regulating, they're all monitoring themselves. So in that circumstance, you could say, I have got post-placement inspection because they're looking after they've placed it. So they're doing it inside their machine. If they're not doing that, then they are leaving a gap in their understanding of their process, because if you've got a component at the end, for example, and it's raised, why is it raised? A component was dropped. If a component was dropped, why didn't you see it? Oh, because it dropped onto a pad. It wasn't meant to be there. I wasn't looking there, says the pick-and-place machine. So,
depends on the value chain, I guess. If you have very high-cost components placed and you want to inspect not only XY, but also cracks, damages, so before the next production step, you can do a repair, then you might save a lot of damage.
And that's why it's so important, because the minute you put it through a reflow oven, then you're into money, you're into a repair situation. Gentlemen, we could obviously go on a lot longer. You are a very experienced panel, and it's been a nice, robust debate. I want to thank you all for joining us today. Herald Eppinger from Koyoung, Dr. Subodh Kulkarni, CyberOptics, Carsten Salewski from Viscom, and of course David Bennet here from Mixtec. Thank you, gentlemen.
Thank you very much.
Thank you,
Trevor.
And thank you for joining us.